Well, that's all. Which picture? Oh, all right.
Yeah,
Okay.
all
right. Which picture was that? That was the. That's the light tonight.
Yeah, I would see. I said,
You might look serious.
you wasn't smiling.
Well, I was smiling. That was normally, you know me, always smiling. Right?
Yeah, 5 points. Then we can question. Let's see if people come.
Right.
Um,
Hi. Good night, everyone. Good night, and welcome to Moyo Math. We'll just give persons time to join before we get started. Ever join it?
yeah, good. Yeah. Oh, you have it on WhatsApp?
Yeah. Laughing. Because I set up for them this morning.
All right, that's right.
You can move that the blue curtain.
Yeah, if you want,
Yeah. Going through? You can clear?
Yeah, hello. I take it. That's I like
Right. 19? All right.
Yeah, we
so
have
start.
5 minutes, 3 minutes.
All right. All right. So for those who are on, we're going to get started in just about 2 minutes again. You just give more persons time to join before we get started. So in about 2 minutes. Okay? Wow. 600 details there. Okay. Last time. All right, so good night to all, and let us get started. So again, welcome to Moyo Math. Welcome. And tomorrow is a big day. And I hope you're all ready. I hope you are all, focused and, ready to enter that exam and do an excellent paper. So at the end of it all, you can achieve that distinction in mathematics. And it can be achieved. If some of us are doubtful, don't be doubtful. You can achieve it. What we're going to do tonight we are going to, just look at some of the key topics that we expect to see in the examination, and hope that, those topics and questions come in the exam tomorrow that can help you to pass the exam and pass well. All right. Now, the live will not be very long tonight. The live may be about 2 hours, but we are going to try to push it as much as possible so we can cover what I have planned for tonight. So let's get into it. What we want to do tonight, we want to look at, some of the key topics we're going to see in the first first half of the paper, because you know that your paper will have questions 1 to 7, and then you have the latter part of the exam where you have your functions, algebra, graphs, you have your geometry, trigonometry, you have your vectors, you have your matrices. Now, in last night's live, I would have done a bit of matrices and I would have touched on a bit of vectors. So what we want to do tonight is to look at 1 or 2 questions on circle theorems, which often always come, in fact, bearings. So you want to make sure we understand bearings. We're also going to be looking at completion of squares. This is under functions and relations. We look at a bit of completion of squares tonight to make sure that, you know, students can complete the square. They can solve simultaneously a linear and non-linear equation, which sometimes comes, but when it comes for a lot of marks. So we want to make sure we can treat with that as well. And we may look at a vector question tonight, right? So we look at a vector question, probably touch on a matrix question also. In the early part of the paper, we look at a bit of algebra, you know, solving a pair of equations simultaneously, being able to factorize expressions, which you see in the exam always. We look at a bit of coordinate geometry. So coordinate geometry always comes, and a bit of functions as well, all right? So remember, the live will be about 2 hours tonight, so let's see what we can do within that time. So let's get into it. So we are looking at here the first question, and this here is a question where we have solving a pair of equations simultaneously, and we have factorizing some expressions shown. The first is to replace those variables in the expression with numbers. And of course, you know, we want the session to be interactive, so if anyone has any questions, feel free to ask questions. Do not hold back. This exam is tomorrow. It's a key and very important exam, so don't hold back. Ask your questions, okay? I have my assistant here who will relay the questions to me, and I will answer accordingly. So let's look at the first question. We have here m is equal to -2 and n is equal to 4. And we want to calculate or find the value of, and we have in brackets 2m plus n, and we also have in brackets 2m minus n. Now, of course, when we see a question like this, all we're going to do is to replace these variables, or those letters, they are called variables, with these numbers shown. Yeah, so we're just going to replace the variables with numbers, and
so she said that you can't see, right?
Or you can't see the...
Yeah, so it's coming in and out.
Oh, it's coming in and out.
So what you have to do is, when you read the question, just basically putting question on the board.
Okay. All right. So what I'm going to do for those of us who are having challenges seeing the question on the board, what I will do is actually write the question, yeah, and of course, you know, carry out the solution to the question. So what is here, I'm going to write here. Okay. So if that's okay, let me know. Let me know if you're seeing what I'm writing here. Are we all seeing what I'm writing? Everybody seeing what I'm writing? All right, nice, good. So let us replace these variables m and n with the value shown. So this will be in brackets. I'm going to put 2. I'm going to replace m with -2. So we put -2 in brackets and make sure this is shown. The substitution part is shown because you're going to get 1 mark in the exam for doing such. Plus, we replace n with 4, close brackets, open brackets. This is 2. We replace m again with -2. So we put -2 in brackets. So make sure you put it in brackets. Subtract, replace n with 4. Close big brackets. Let's simplify what we have in this first, and these are called binomials, by the way. So let's simplify what we have in this first binomial, which are big brackets. And what we're going to get here, what? This becomes 2 by -2 is -4, plus 4, close big brackets, open big brackets, 2 by -2 is -4, subtract 4, and when we are simplifying further, let's simplify what is inside of each binomial. -4 plus 4 is 0, times -4 subtract 4 is -8. But of course, to simplify this further, this simply means 0 multiplied by -8. And 0 multiplied by anything, of course, will be 0. So our end result here will be 0. So what we're doing is, and this is something you can certainly see in question 2 of the exam paper, simply replacing variables with numbers. Where you see those variables or letters, you substitute or you replace them with numbers and make sure brackets are shown. All right, and of course we simplify to get our final result. And keep in mind, in that exam tomorrow, make sure show steps, steps, steps. Don't leave out any steps at all right? Because you get marks for steps. All right, let's look at B. So we all clear on that first one? Let me see, show up thumbs up. Let me see if we're all clear. Everybody be clear on that first? Show up thumbs. We all good? Yeah, seen thumbs? All right, nice. So let's move on to B. So we have here for B, we want to solve the pair of equations simultaneously. So let's make sure, class, we can solve a pair of simultaneous equations. So we have our 2 linear equations, and what we're going to do tonight, we're also going to look at solving a linear and a non-linear. We're going to look at that tonight. What we have here, class, is a pair of linear equations, and you can use either the method of elimination or the method of substitution. But you know, most students prefer the method of elimination. So let's solve the pair of linear equations simultaneously. We have 5x plus 6y is equal to 37. And we also have here, this is 2x plus 3y is equal to 4. Good? And we know if you have to solve a pair of linear equations simultaneously, our objective is to solve for the coordinate of the point of intersection, right? So you have a linear equation. So the coordinates of the point of intersection, a pair of linear equations, they both will meet at a common point, and the objective is to find for the coordinates of that point of intersection, a value of x and a value for y. So to do so, we can use any one of 2 methods, the method of elimination or the method of substitution. Most students go with elimination, so let's do elimination. So to eliminate, we can eliminate any one of these variables first. Either you want to eliminate x first. If you eliminate x first, you solve for y, and then you have to come back and solve for the first variable you eliminated. Or you can eliminate y first, you will solve for x, and then you come back and solve for the first variable you eliminated. Me, preferably, I like to eliminate the first variable, x. So, the first step is to label. So, we label 1, 2. To eliminate x or to eliminate anything, they must be the same. Must be the same. So, right now, this is 5x and 2x. They are not the same. This is 5x, that's 2x. So, what we want is to ensure that those 2 terms are the same terms. So, those numbers located in front of x, we want them to be the same number. Okay? So, one easy way to obtain the same number is first to get the lowest common multiple of these 2 numbers. The lowest common multiple of 5 and 2 is 10. So, let's make both numbers in front of x 10. So, to make this number in front of x, this 5 here, 10, it means I have to multiply. I'm going to multiply equation 1 by 2. And to make this number in front of x in your second equation, 10, I'm going to multiply equation 2 by 5. So we're going to get 2 new equations where those numbers located in front of x or your terms involving x are the same. So let's multiply. 5x by 2 is 10x, plus 6y by 2 is plus 12y, is equal to 37 by 2 will give us, that will give us 74. Yeah? And we call this equation 3. Let's multiply all those terms in equation 2 by 5. Remember, every term you're multiplying by 5. Every term I multiplied by 2. So 2x by 5 will give me 10x. Plus 3y by 5 is plus 15y. And 4 by 5 is 20. And I'm going to call this equation 4. So now that I have 2 new equations where my terms involving x are the same, or my coefficients or numbers in front of x are the same, I can comfortably now eliminate them, right? So let's eliminate. So we're going to eliminate by doing what? We're going to subtract. So remember, if you have to eliminate something and you have the same variable, you can eliminate it by subtracting. If you have 2 and 2, you can easily eliminate by subtracting. So we have 10x and 10x. So let's eliminate by subtracting both equations. Now, what I like to do, and it's important to show your subtraction sign, what I like to do personally is to place my subtraction sign in between my terms. So let us now subtract. You draw your line, make sure that line is drawn, and let's subtract. 10x subtract 10x will be 0. So therefore, your terms involving x are eliminated. So no longer will you have your terms involving x. Now, this part is important. What you see vertically here, we're going to write it horizontally. Some students like to subtract it as is. Of course, if you master it, you can. But just to avoid making any mistakes, I will always advise, write it down. This will be 12y. Positive 12y is the same as 12y. Subtract, I have my subtraction sign. Positive 15y is the same as 15y. So what I see vertically, I write it horizontally. Is equal to, this is what I see vertically, I write it horizontally. 74 subtract 20. So let's work this out. So we know that 12y minus 15y will give us negative 3y. And we know 74 minus 20, that will give us 54. So for us to solve for y now, it means I have to remove negative 3 from in front of y. And because this is negative 3 multiplied by y, the opposite of multiplication is division. So I divide negative 3y by negative 3, and what is done to one side, I must do to the other. So my two negative 3's on the left will divide into each other to give 1. So you're left with y. And let's divide negative 3 into 54. A plus divided by a minus is a minus. 3 into 5 is 1 remainder 2. And 3 into 24 is 8. So you're going to get here negative 18. And after we have found y, we need to find what? X, because remember that's the objective, to find the coordinates of the point of intersection, x and y. So having found y, let's find x. So to find x, we're going to substitute y equal to negative 18, this first variable we got, into any one of the original equations. You pick one, any one. If you see this in your exam tomorrow, go ace it. You place it into any one of the original equations. So let's pick one. I'll go with equation 2. So substitute y equal to 18 into equation 2. So I state equation 2, which is 2x plus 3y is equal to 4. And where I see y in equation 2, I am going to replace it with negative 18. So this becomes 2x plus 3, open brackets, I replace y with negative 18 is equal to 4. And this now will simplify to become 2x plus 3 by negative 18 will give me negative 54 is equal to 4. And therefore, I can solve for x. So in solving for x, I'm going to remove negative 54 first by adding 54 to both sides. Some of us, are accustomed to taking negative 54, bring it over to the right, change the sign, no problem. This will be 2x is equal to 4 plus 54. So I like to use the balancing method where you add 54 to both sides. That's how I like to explain it. And we're going to get what? 2x is equal to 4 plus 54, which is 58. And therefore, to find x, we divide both sides by 2. So x is equal to 2 into 5, 2 2's are 4, remainder 1, 2 into 18 is 9. So therefore, we would have solved our pair of equations simultaneously, and we would have found the value of x and y. So therefore, x is equal to 29, and y is equal to negative 18. And it's always good to state that at the end. So we have here a pair of equations, which we have to know how to solve simultaneously. And again, in matrices, you will see sometimes a question where you have to solve a pair of equations simultaneously, and you have to use a matrix method. So once time permits, we're gonna do one before we close off, right? So let's make sure we know this. Are we all clear? Can I see show up thumbs? Thumbs up. We clear on what was explained there? Let me see those thumbs. Everybody, we good? Again, if you have any questions, do feel free. Ask your questions. Make sure you're clear. Right, so sorry about that. You know, I'm just having a discussion here with my assistant. All right, so let's look at now part C. Now, part C deals with factorization. So I'm going to place the expressions on the board, and what I will do is, of course, close off the PowerPoint, so the PowerPoint would not affect your vision. All right, so I'm going to put the question on the board, and then I'll just close off the PowerPoint so we can see the question clearly. So I'm going to erase. Now, guaranteed in your exam tomorrow, class, guaranteed, you are going to see factorization. No ifs, no buts. It is guaranteed you're going to see an expression to factorize. And we want to make sure when we see our expression, we can comfortably factorize. Okay, let's hope that you get 3 like this. Yeah, so that's an easy 2, 4, 6 marks in the bag, right? So let's treat with the class. We want to factorize completely. Right? We want to factorize completely the following expressions. We have 1, 4x squared minus 25. So we want to factorize that expression. So let's look at that expression. So to factorize this expression, again, you have to know your methods of factorization. Okay? So they wouldn't tell you factorize using a specific method. They'll just ask you to factorize, and you have to now recognize the method. This here, the method we're going to use is the method of the difference of 2 perfect squares. So the difference of 2 perfect squares. And the reason why we're using that method, because 4x squared is a perfect square. 4x squared can be expressed as a product of the same 2 factors. 4x squared is 2x. By 2x, the product of the same 2 factors. That's why it's a perfect square. 25 is also a perfect square. It can be expressed as a product of the same 2 factors, 5 by 5. And the subtraction sign between it represents the what? Difference. Hence the reason why it's called a difference of 2 perfect squares, right? That's why that's the method. So to factorize, it's an easy process. This is the easiest method of them all. We're going to put 2 sets of brackets, which are binomials. And this is what we're going to do. In your first binomial, because 4x squared leads, we're going to take the factors of 4x squared and we're going to place it first in each binomial. So you're going to put 2x in one, 2x in the other. And because 5 comes after, we're going to put 5, which are the factors of 25, next in each binomial, 5 and 5. And you always separate. You put a positive sign in one, you put a negative sign in the other. And it doesn't matter the order. You can put negative in the first binomial and positive in the second. All right? And this here will be your final result. You have factorized it. Keeping in mind, what is factorization? Factorization is representing an expression, this expression, as a product of factors. Product means to multiply. So when anyone asks you what is factorization, that is factorization. You take an expression and represent it as a product of factors. So let's look at the second question from the exercise I have here. We have 6p minus 9ps plus 4q minus 6qs. All right? We want to factorize that expression. So for us to factorize this expression, again, you have to be able to recognize the methods, right? Now, the method we're going to use to factorize this expression will be the method of grouping. Why? Because you have 1, 2, 3, 4 terms. That's when you know you're going to use grouping. So in your exam tomorrow, if you see an expression looking like this with 1, 2, 3, 4 terms, the method you're going to use is the method of grouping. All right? So that's the method we're going to use. And with the method of grouping, it's easy. What we're going to do is divide these 4 terms into 2 pairs. So what I like to do is draw a dotted line between my 2 pairs. Each pair will have 2 terms. Good? And what we're going to do is factorize each pair. So I'm going to use what you call the highest common factor method to factorize each pair. So let's factorize this first pair using the highest common factor method. You look at the numbers 6 and 9, we try to identify the highest common factor of 6 and 9. And the highest common factor, that number that can divide into 6 and 9 without a remainder, obviously the highest factor will be 3. So you take out 3 as your highest common factor. That's the highest factor that can divide into 6 and 9. You also look, we see variables common to each term. So what variable is common to each term? P. So we pull out P as well as part of our highest common factor. Now that we have identified what's the highest common factor, we're going to divide this highest common factor now into each term. So in dividing, we're going to say 3 into 6 is 2 times divide P into itself, which is 1. 2 by 1 gives me 2. And let me divide 3p into negative 9ps. So when I'm dividing, a minus divided by a plus is a minus. Let me divide. 3 into 9 is 3 times, there's a multiplication sign between all those variables and numbers. That's why I'm putting a multiplication sign there. P into p is 1 and s remains. So 3 by 1 by s is 3s. So that's me factorizing this first pair. Let me factorize the second pair now. And always remember, the sign controlling the first term of the second pair you write down automatically. And now let's pull out what is common to the second pair. Clearly, look at the numbers 4 and 6. 2 is common, you pull it out as your highest common factor. Q is also common, you pull it out as part of your highest common factor. And now let's divide that into each term. So, plus 2q into plus 4q will be what? Plus 2 into plus 4 is 2 times q into q is 1. 2 by 1 is 2. Plus 2q into minus 6qs. A minus divided by a plus is a minus. 2 into 6 is 3 times q into q is 1 and s remains. 3 by 1 by s is 3s. But the good thing about this class, the good thing about it, when you factorize, you recognize you have the same thing in brackets. And when you get the same thing in brackets using this method, you know you're on the right track. You're doing this thing right. So you just have one more step to carry out to get your final answer. We're going to further factorize. That is, you see this 2 minus 3s? You're going to take it out as a factor now. Let's pull it out. So you put 2 minus 3s. Let's pull it out as a factor. And then what you're going to do, just to make it easy, to make it real easy, you take out the 2 minus 3s, which is common, and what remains, which is a 3p plus 2q, you simply place that in the other bracket. Make it real easy, right? So I'm not going to use any technical terms, just to make it easy. The exam is tomorrow, and if we get an expression to factorize, and you're using this grouping method, when you factorize and you have the same thing in brackets, just to make life real easy, you pull out your 2 minus 3s, good, and what remains, which is your 3p plus 2q, you place in the other bracket. And it doesn't matter the order. You can have this first and your 2 minus 3s after. It doesn't matter the order, okay? So this will be the result of the second expression. Let's look at the third. We want to factorize this expression here. We want to factorize 3x squared plus 4x minus 4. Again, this is a common expression you see in the exam, right? And the method we're going to use here is the method of, anybody can tell me? Anybody know if you have to factorize that, what method? Let me see if anyone can tell me. If you're ready for your exam tomorrow, what method of factorization do you think we're going to use for that? If you see that in the exam. Anyone? Ah, nice. So whoever said quadratic, you're on point. So this is the quadratic expression. So if you see that in your exam tomorrow, ace it. Question 2, ace it. Okay? So what we're going to do to factorize this, all quadratic expressions look like this. It is of this form. Ax squared plus bx plus c. And to start off, you are going to multiply a by c. So what is understood as a? 3 is understood as A, and what is understood as C? Negative 4. So you're going to multiply 3 by negative 4, which will give you negative 12. And what you want now are 2 factors of negative 12. When multiplied, will give that negative 12 you have there, but when added or subtracted, can help you to get that middle term 4x. Good? So you want 2 factors of negative 12. When you multiply them, you're getting back that negative 12. But if you add them or subtract them, you can get the middle term plus 4x. And the 2 factors of negative 12 we're going to use will be, we're going to use 6 and negative 2. Good? 6 by negative 2 will give us negative 12. And if I state this in the order, I take 6, I attach x to it. So you see here 6x. I take negative 2, I attach x to it. I know 6x minus 2x gives me 4x. And there are some rules of the signs of the quadratic that can help you too. Once there's a minus sign in front of the constant, this is known as a constant, right? Yeah. It means that the signs of these terms are different signs. So you saw they're different. And once you have a plus sign in front of your x, your term involving x, then it will tell you the larger term is controlled by a plus. So once these signs of the quadratic corresponds with the signs of your terms, you know you're on the right track, right? So there are some rules of the signs you need to know. But I mean, time is against us, right? So this will be what? I'm going to rewrite my 3 terms as 4 terms. I'm going to write 3x squared. I'm replacing plus 4x with plus 6x minus 2x minus 4. And what we see here now, what we just did, the method of grouping. We have how many terms? 1, 2, 3, 4 terms. So all you're going to do now is apply the method of grouping to get your final answer. So let's pay off. You know what grouping? You see this in the exam, you pay off. Let's factorize the first pair. What is common to my first pair? Clearly 3 is common to 6. And itself 3 is common to itself, 3 is common to 6. The highest common factor. If you look, you have x squared and x. So what is the highest common factor? We're going to pull out x. Good? So we pull out x. We pull out the lower of the 2 powers. X has a power of 1, this has a power of x squared. You pull out the lower of the 2 powers, and you're going to divide 3x now into each term. So 3x into 3x squared will give us what? This will be 3 into 3 is 1 times x into x squared is x. 1 by x will give you x. And let's divide 3x into plus 6x. A plus divided by a plus is a plus. 3 into 6 is 2 times x into x is 1. 2 by 1 is 2. Let's factorize the second pair. The sign controlling the first term of the second pair, you always bring down. That's the first thing you bring down, right? When it comes to the second pair, whatever sign controls the first thing, you bring down at one time, right? And then let's pull out what else is common. Clearly, 2 is common to itself and 4, so we pull out 2. So you have negative 2 as the highest common factor, right? And let's divide now negative 2 into each term. So negative 2 into negative 2x. Negative 2 into negative 2 is 1. And of course, x remains. 1 by x is x. And let's divide negative 2 into negative 4. Negative 2 into negative 4, a minus divided by a minus is a plus. 2 into 4 will give you what? 2. And what we experience with grouping, once you have the same thing in brackets, you know you're doing this thing right. So we have the same thing in brackets, so we know we're on the right track. You're doing this thing right. So your final step now is to take out what is common, x plus 2, and what remains, just make it easy, no technical thing. Just take what remains, 3x and minus 2, and we put it in the other bracket. And again, it doesn't matter which one is first. 3x minus 2 can be first, x plus 2 is after. And we have factorized the expression. So let's make sure everybody that we're good with factorizing these expressions. Everybody, we good? Let me see a thumbs up. We good with what I did here? Because you know you're going to see factorization in your exam tomorrow. We good? Let me see a thumbs up. Thumbs up. We good? Yeah? See those thumbs? Right. Okay. So what we're going to do next is another topic you can see in the exam. and I'm going to erase the information here. So if you have to write down anything, you know, just give you about 2 seconds to write down quickly or take a screenshot. Yeah. So we're going to look at now what you can see in the exam tomorrow, and it comes almost every year. Coordinate geometry. You see it sometimes in the early part of the paper. Sometimes you see it under the geometry and trigonometry part of the paper, right? So you want to make sure you understand coordinate geometry. So let's look at a bit of coordinate geometry, and we can, you know, understand questions in relation to it. So there are a number of formulae you need to know. So please remember your formulae. So I'm going to erase. So let's look at some coordinate geometry. So if you see this in the exam tomorrow, easy marks in the bag. So let's look at this. So we have here now. So let me know, have you seen this question? Of course, I'm going to write it on the board, but have you seen the question? Let me know, thumbs up if you see any question. Thumbs up. Any question? So, all right. So this is something we're going to work on, though. We're going to work on this. So you have 2 points. S, whose coordinates are 6, 6. T, whose coordinates are 0, -2. So we have those 2 points, okay? What they ask us to do, they ask us to find, and with coordinate geometry, remember, you're dealing with a line drawn between 2 points, and you have to be able to find the gradient of the line, the equation of the line, midpoint of the line, length of the line. So make sure you know those formulae, because most times, almost every year, you see a question on coordinate geometry, and they ask you to find those things, all right? So 1, let's find the gradient of this line ST. Good? So the line L, they call ST L, right? So they call it L. So that's how they call the line ST L, right? So let's find the gradient of ST, or the gradient of this line L, okay? So to find the gradient, there's a formula you need to know. So everybody, please make sure you know this formula before your exam tomorrow, and I'm sure most of us know it. Let's make sure it's solid. The gradient is what? Common M is equal to y2 minus y1 over x2 minus x1. Change in y over change in x. You should know that formula, right? High possibility you're going to see a question where this will come into play tomorrow. And what you do, class, before you substitute, you label the coordinates. This is x1, y1. Anyone can be x1, y1. I like to call, based on the order of the letters of the alphabet, because this is S, I like to label that x1, y1. And this is T, I'll call this x2, y2. So let's substitute. M, your gradient, is equal to y2, which is -2. And the importance of labeling, subtract y1, I'm going to replace that with 6. Over x2, I replace that with what? 0. Subtract x1, I replace that with 6. So M, the gradient, will be -2 minus 6 will be -8 over -6. And we're going to get our gradient here, M, as a minus divided by a minus is a plus. And we can simplify it. 2 into 8 is 4, and 2 into 6 is 3. So we're going to get 4 over 3. Yeah? So that's the gradient of that line. And just remember, anytime the gradient is a positive number, the gradient, what's the purpose of the gradient is to determine the slope of the line. So if the gradient is positive, note that your slope will be like that. It's known as a right-hand slope. If the gradient is negative, you're going to have a left-hand slope. All right? So that's the first. The next class, which we have to know, part 2, is to find the equation of the line. So the equation of ST, or the equation of the line L. Good? So to find the equation, please make sure you know this formula as well for tomorrow, right? The equation is y is equal to mx plus c. You should know that formula. And note in that formula, only 2 letters in that formula we want to replace with numbers at the end of your representation. M and C, You must replace with numbers. The y and x will stay as is. All right, so that will be your form where m and c are going to be replaced with numbers, y, x stays as is. So, what number am I going to replace m with? I calculated that in part 1, my gradient m, which is 4/3. How am I going to find c? So to find c, this y here, I need to replace this with a number. M here, I need to replace with a number, which I already know. And x here, I also need to replace with a number. Good? So to get that number, or those numbers to replace x and y with, you use the points. You use the points here to help you. So take any one. It doesn't matter which one you take, you get the same answer. Let's go with t. Most students will go with t, right? You see 0, see -2, it looks easier than s, so you'll go with that one. And it doesn't matter, you get the same answer. 0, -2, you know 0 is x, -2 is y. So you're going to replace this y with the number -2. So y is replaced with a number. You replace m, the gradient, with 4/3. So replace m with a number, and you're going to replace x with a number, which is 0. But be careful, you're not just going to write 0. This is m multiplied by x. It's going to be 4/3 times 0. So you make sure you put 0 in brackets, plus c. So we're going to get what? -2 is equal to 4/3 by 0 is 0 plus c, and 0 plus c will give you c, and therefore c is equal to -2. So you have found the c. But that's not the end there, you know. When you're asked to find the equation of a line, students stop here and say, hey, I found the equation. That's not the equation, huh? To get the equation, you have to now write it back in that form. So you're going to write it as y is equal to m, which is 4/3, x, and you replace c with -2. And that there is the equation of your line, all right? So make sure we know these two very important formulae, right? No gradient, no equation. Let's look at now, next on the list will be midpoint. So let's look at the midpoint. So 3. So I'm erasing here. And let's look at midpoint. So 3, the midpoint of ST. And again, make sure you know this formula, midpoint. It's very likely you can see this tomorrow as well. And if you see tomorrow, you'll smile and say, yes, you know, I'm happy I did some you know, additional classes with Mr. Moyo, you know, before exams. Yeah, you'll be happy for that. So we have here. So the midpoint class will be the average of the x coordinates, and average of x, if you have to find the average of anything, you add and divide by the total number. Average of your x coordinates, comma, average of your y coordinates. y1 plus y2 over 2. Make sure you know this formula. Average of your x coordinates, so you take x1, you add x2 and divide by 2, comma, average of your y coordinates, y1 plus y2 divided by 2. And once you know your formula, all you're doing now is substituting. You're replacing x1 with what? 6, plus you're replacing x2 with what? 0, all over 2, comma, you're replacing y1 with what? 6, plus you're replacing y2 with -2. And please make sure you put -2 in brackets. Good? All over 2. And you make sure you put -2 in brackets to separate these two signs. So we're going to get what? 6 plus 0 is 6, all over 2, comma, a plus by a minus is a minus. So that's why I put it in brackets. Plus by a minus is a minus. 6 minus 2 will be 4, all over 2. And therefore, the midpoint will be 2 into 6 is 3, 2 into 4 is 2. So make sure, class, you know how to find the midpoint. Make sure you know how to find your equation. Make sure you know how to find gradient. So let's look at the last of this question. And if they bring something like this tomorrow, you should be smiling. If they give you all 4, right? Yeah?
How important is the working? How much marks?
Right. So based on the question, someone asked a question. The working is most important. That's the most important part of your question. You get marks for steps. This is why I will always stress steps, steps, steps. Sometimes the answer is secondary. You just get 1 mark for the answer. If you have a question carrying 4 marks, the bulk of your marks will go for working. So hence the reason you show your formula, you show the substitution into the formula, and of course you show the breakdown to get the final answer. But this here, we'll just carry 1 mark. You will get, if this is a 3-mark question or 4-mark question, 1 mark for this, 3 marks for everything else. So the working is extremely important. Don't play with that, all right? Yes, I'll be doing a bearings question, yes. So I'll be doing a bearings tonight, right? Yeah? So I'll do a bearings. So let's look at the last here, which is 4. Yeah, and bearings, you know, certainly if you look at the history of the paper for the past 4 years, you saw a bearings question. So we do our bearings, right? Certainly. So we have here 4. We want to find the length of the line segment here. So the length of TS. I'm sorry, ST. So we want to find the length of ST, right? So what are we going to do? We're going to use our formula, and that formula is what? The square root. And make sure you know this formula as well. Square root, open brackets, x2 minus x1 in bracket squared. Yeah? Plus, open bracket, y2 minus y1 in bracket squared. Yeah? So you have your change in x squared plus your change in y squared, and of course the square root symbol placed over it. Yeah? So make sure you know that formula. Change in x squared plus change in y squared, and of course you find the square root of everything. Yeah? Which stems from Pythagoras' theorem. So let's substitute. This becomes what? The square root. And we place an x with what? 0. In brackets, of course, subtract, and we place an x1 with 6. Of course, both within brackets, raise to your power of 2, don't forget your power of 2, plus, open brackets, I replace y2 with what? Negative 2. Subtract, I replace y1 with what? 6. In brackets as well, raise to the power of 2. I simplify, this becomes the square root of 0 minus 6 is negative 6. In brackets squared plus negative 2 minus 6 will give us negative 8. In bracket squared, and this becomes the square root of negative 6 squared is 36. Plus negative 8 squared, of course, will be 64. Remember, negative 6 by negative 6 will be positive 36. Negative 8 by negative 8 is positive 64, right? And of course, you have your plus sign separated. And we're going to get here the square root of 36 plus 64 will be 100. And the square root of 100 will give us 10 units. All right? So the length of ST will be 10 units. All right? So let's make sure we're good with that. We're good with that. So, everyone, we clear on those 4 important formulae. Let me see a thumbs up. Thumbs up. You see this in the exam tomorrow. You know you're going to ace it. Let me see thumbs up. Yeah? Thumbs up? Right. Nice. So, let's look at another. So, sometimes with a coordinate geometry question, you know, they may bring something like this. I know that persons are having challenges with seeing the PowerPoint. So this is a graph. So tell me if you've seen or not, okay? So I'm going to erase here. All right. So you may have some challenges seeing that one. Tell me if you've seen that one. You seen that one? One person? Okay. Too bright. All right, yeah, we really have to do something about that lighting so we can improve the vision, right? So persons can see this. Yeah? But basically, let me just draw what I have on the board here and let's make sure, you know, we understand how to trick with this, right? Now, so with the next slide, of course, you would have written exams then, but encourage others to, because AdMath is coming up soon, so I may do a live for AdMath, yeah? So we work on the lighting, for the next slide. So this is what we're seeing here. We're seeing here y-axis, x-axis, and we have a line drawn here. So with your coordinate geometry, sometimes you see where they will give you a line and they'll give you some information, of course. So we have here this line L, and it cuts the y-axis at 3, and it cuts the x-axis at 6. And we have a line M. It cuts the y-axis at -2. Good? So this is M, line M, and this is line L. Good? So they asked some questions. The questions they asked, and this actually came from January 2023, all right? Which was January exam there. They asked now, and this is important to know with your coordinate geometry. Let me close down this. They asked to write down the coordinates of the x-intercept of L. So x-intercept of L. So this is line L here. So the x-intercept is where that line cut or meet the x-axis, which is here. And they asked for the coordinates, not just the point 6, not just the value 6. They asked for coordinates. So we have to understand when a line meets the x-axis, automatically we should know that the y coordinate will be 0. That is automatic. Good? And of course, it meets the x-axis at 6. So the x coordinate will be 6. So when they ask for the coordinates of the x-intercept of L, this is line L, and it meets the x-axis at 6. The coordinates will be, so coordinates of x-intercept of L, we're going to state that as 6, 0. All right? Pretty straightforward. They also ask for the y-intercept of line L, line M. The coordinates of the y-intercept, so coordinates of y-intercept of line M. So that's straightforward. The y-intercept is where that line will obviously meet the what? Y-axis. So where is going to meet the y-axis? Here. So if you have to find the coordinates of that y-intercept, we need to know automatically that the x-coordinate of that y-intercept will be 0. So this is something you should know automatically. So you may see a linear programming question, and you have to know this to draw your linear functions. And the y-coordinate is automatically -2. So the coordinates of the y-intercept of M will be 0, -2. All right? So pretty straightforward. Easy marks in the bag there if that comes tomorrow. But we have another part of this question. We have this part of the question which says, so this was part A. Part B says now, the equation of line L. You see this line L here? This line L has an equation. So the equation of line L, and let me just write it on line L. They gave it as x plus 2y minus 6 is equal to 0. That's the equation of line L. Let me write it here. Equation of line L, which is x plus 2y minus 6 is equal to 0. That's the equation of line L, right? So the equation of line L is given by that. They want us to find the value of k given that the point 9k lies on the line. So we have some point 9k lying on this line L, right? Let's assume 9k is here. They want us to find this value of k. Very important, class, for us to treat with this. Any point that lies on a line and you have the equation of the line, the point will satisfy the equation. What do I mean by that? So if x is 6 and y is 0, when I replace x with 6 and y with 0, I'm supposed to get 0. it means that this point will satisfy the equation. So where I see x, I replace it with 6. Where I see y, I replace it with 0. And when I work it out, I must get 0. If I take any point on this line and I replace x with that, with its x coordinate, y with its y coordinate, when I work it out, whatever point I substitute must satisfy the equation, must give 0. So the same for this point 9k. If I replace x with 9 and y with k, obviously it will be equal to 0 and will also allow me to create an equation to find k. Because you have to remember, in mathematics, anytime you have to solve an unknown quantity, an equation must be created. You have to create an equation. So let's look at it here. This point 9k, so point 9k lies on L. That point 9k lies on L. So if you see a question like this in the exam tomorrow, this is what you're going to do. All you're going to do is replace x, this is x, and that's y. You're going to replace x with 9 plus 2. You're going to replace y with what? K. Minus 6 is equal to 0. That point satisfies the equation. So what you're going to do now is solve for k. So this will be what? 9 minus 6 is 3 plus 2k is equal to 0. Yeah? And what you're going to do, of course, is solve for k. You have an equation there where you can solve for k. So this becomes 2k is equal to minus 3 from both sides. So you're going to get 0 minus 3, which is negative 3. And therefore, you can make k the subject by dividing both sides by 2. 2k over 2, negative 3 over 2, and therefore k is equal to negative 3 over 2. So that's the value of k, or the y coordinate of that point, which will satisfy the equation. So when you plot this point, it's 9, and it's going to be negative 1.5 or negative 3 over 2, or negative 1.5. But any point on this line must satisfy. So when you substitute x with the value, y with the value, it must give us 0. Where the 6 went? You're saying here 9 minus 6. 9 minus 6 will give you what? 3. So you're simplifying it. You see that? So you're replacing x with 9 plus you're replacing y with k, 2k minus 6 is equal to 0. And then you're going to simplify what you have on the left. So you're going to say 9 minus 6 is what? 3 plus 2k is equal to 0. And then you can solve for k. You see that? Clear what I explained there? Let me see thumbs up. Yeah? So clear how that 6 disappeared? What you did is just group like terms. You just simply did this. You can rearrange 9 minus 6 plus 2k is equal to 0. So let's rearrange. So 9 minus 6 will give you what? 3 plus 2k is equal to 0. And then you solve for k. See that? Right? Nice. So just rearrange and you just make it happen. And you solve it. Yeah? So just remember, if you see a question like this in coordinate geometry, and I've seen it about 2 or 3 times, where you have some point and you have an unknown as one of the coordinates, and they ask you to find that unknown. And remember, in math, if you have to find an unknown, you have to create an equation. But any point on a line will satisfy. So you just substitute for x and y, and you solve to find what is the unknown. All right, now, they ask us, and this is a common question you see in the exam. Find the equation of the line M in the form y equal to mx plus c. They want us to find the equation of this line M. Good? In the form y equal to mx plus c. They want the equation of that line M. So, with that question, they gave us the 2 lines, and if we have to find the equation of this line M, what we need to recognize, class, let me make sure I state some key points here. They want us to find the equation of this line M, part C. Equation of line M. So they want us to find the equation of this line. The first thing, class, when you see the first word in that question, well, the third word, find the equation. Key word in that question is equation. Find the equation of the line M. The equation of the line M is of the form y equal to mx plus c. By the time they ask you to find the equation of a line, this is the form you're going to state automatically. All right? But to find the equation of a line, you know from what we did when we looked at the first question on coordinate geometry, you need to find a value for what? M, which is your gradient. And you need to find a value for C, which is your y-intercept. And remember, the y-intercept is where the line cut or meets the y-axis. Good? Yeah? So we need to find M. If you look at this line, class, we don't know what's the gradient of that line. Yeah, we don't know. But we can find the gradient of that line by taking 2 points on the line, 2 easily recognizable points, and we can use our formula that we just learned to find the gradient. So just looking for 2 easily recognizable points. And because you're not seeing the graph, the 2 easy recognizable points on this line will be the y-intercept, whose coordinates are 0, -2, right? And you also have this point here, which is very clear on the graph, whose coordinates are 2, 2. Those are 2 easily recognizable points on the line. So once you're able to recognize 2 points on the line easily, you have your y-intercept, which is 0, -2. You have that point on the line M, and another easily recognizable point will be that point 2, 2. If you have January 2023, question 4, you're going to see where this point 2, 2 is easily recognizable. Yeah? So someone have a question? Go ahead.
What is sum is y equal mx plus cy?
Y equal to
mx plus cy.
Right, so remember, you wouldn't get, now of course, with the equation of a line, right? Normally, of course, it must be of the form y equal to mx plus c. C, of course, is a constant, and that constant is where the line obviously meets the y-axis. And that constant normally will be a value. Good? It's going to be a value. Now, if we want to use a constant as cy, no problem. You can use a constant as cy. But of course, there will be more to that question that will require us to implement if they left the constant as cy. But in general, to find the equation of a line, the constant c is normally represents a number, a value. All right, and they use c. They will use cy. Yeah. So they normally use c. So that's a standard formula. This is a standard formula you must know. Y equal to mx plus c. If you're doing add math, then sometimes with add math, you know, they may go a bit more in depth. Yeah. But that's a standard formula you must know. All right. So when you see cy, clear on that? Thumbs up. All right. Nice. Okay. Good. So to find the equation of this line M, let's find the equation of this line M. And of course, after this, we're going to look at some functions. We look at the 1 or 2 functions. I'll jump to next. I'll probably look at, well, people want to see bearings. I'll jump to bearings. Or if no, I'll look at the completion of squares first. Yeah? Right? Vectors. We'll do a vectors. Right? Completion of squares, and I'll do a vectors. Right? So we'll jump after functions. I'll jump to a completion of squares, and then I'll jump to vectors. All right? And then we'll do the bearings last. So let's look at this. So let's find the equation of this line M. So we have 2 recognizable, easily recognizable points, which can help us to find the gradient. So the 2 easily recognizable points are 2, 2 and 0, -2. So this is how you're going to find the equation of your line M. Look for 2 easily recognizable points, and you find your gradient because you need M. And the y-intercept is straightforward. Look at the y-intercept. Look at where line M cuts the y-axis at -2. All right, so you automatically know you're going to replace C with -2. It's the y-intercept. Good, where it cuts the y-axis. But what you need is M. And to find M, we know our formula. M is equal to y2 minus y1 over x2 minus x1. That's all? And that will require you to use 2 points on the line, but 2 easily recognizable points. So let's use our formula to find the gradient and hence get the equation of line M. Easy. So maybe it's in here. So let's find the gradient of M. Again, first thing, label x1, y1, x2, y2. So M is equal to what? M is equal to, replace y2 with what? -2. Subtract, replace y1 with what? 2. Over, replace x2 with 0. Subtract, replace x1 with 2. So you're going to get your gradient as what? This will be -2 subtract 2 is -4. 0 subtract 2 is -2. So your gradient M is 2. So we found the gradient of that line M, which is 2. And having found the gradient and knowing the y-intercept, which is -2, then the equation of line M, the equation of line M, again, just remember when you mention equation, what should come to your mind? Y equal to mx plus c. What you're going to replace M with? 2. What you're going to replace c with? The y-intercept, which is -2, which is already there on the graph for you. So you're going to simply write this as y is equal to 2x minus 2. And that will be the equation of line M, right? So easy work. So make sure you get your gradient and you check for the y-intercept, yeah? Let's make sure we're clear on this thing. All right, because coordinate geometry, you can certainly see in that exam tomorrow. So make sure you know your coordinate geometry well, right? Now, this is another very important part of coordinate geometry. I know some students may have little challenges with, and let's make sure we understand this. They want us to show by calculation that line M and line L and line M are perpendicular. So they want us to show by calculation that this line M and this line L are perpendicular. What perpendicular means? Perpendicular means they must meet each other at right angles. That's what the word perpendicular means, right? Those two lines must cross or meet at right angles to each other. So we show two lines are perpendicular. This is very important. Notice rule for perpendicular lines. Good? So for perpendicular lines, so this is a part D now. Right? So of course we'll try to send the questions to the description so persons can have access to the questions, all right? And you will see the solutions via YouTube. So let's look at it. We want to find we want to show that line M and line L are perpendicular. So remember this, for perpendicular lines, when you get the gradients of both lines and you multiply them, you're supposed to get -1. If you know the gradients of one line, call it M. And you know the gradient of another line, call this line M1. The gradient of that line M1. And call the gradient of the other line M2. When you multiply both gradients, you're supposed to get -1. That will prove two lines are perpendicular. So when they ask, show by calculation that line L and line M are perpendicular, all you want to do is show one, you multiply the gradients of both lines, you're going to get -1. Yeah? So let's see. We already got the gradient of M. Remember, we took 2 points, 2 recognizable points on this line M, and we got the gradient of M to be what? When we worked it out, we got the gradient of M to be 2. So already we know the gradient of M is 2. But all we need to know now is the gradient of what? This line L. And once we get the gradient of both lines and multiply them, if we get -1, then it will prove that they are what? Perpendicular. All right? So we already know the gradient of M. So let me put here gradient of line M. We know the gradient of line M. We got that before in part C. We got that to be 2. So what is the gradient now of line L? And this part is very important. Good? Now, we can take 2 points on a line if you want. Yeah? Get the gradient and we can multiply them to get -1. That's one way. But you can also get the gradient of line L by using the equation and get familiar with this class. You see what I'm going to do here? When given the equation of a line, you can also find the gradient. So make sure we know how to get the gradient given the equation of a line. So this is how we're going to do it. So you know line L has an equation which is what? X plus 2y minus 6 is equal to 0. Good? We want to find the gradient of line L. So we're not going to take 2 points and find the gradient, even though you can do that. But let's take the equation of the line and find the gradient. So if we see it in a question and they ask you to find the gradient given the equation of the line, we know what to do. So we know that the equation of a line is always of the form y equal to mx plus c. It must be of that form in order for you to find the gradient. You must make y the subject, and the gradient is always that number located in front of x. So you have to make y the subject. Y must stand alone. So you see in this equation here, right now y is not standing alone. So what I have to do is to make y stand alone, get it as the subject. How am I going to do that? I'm going to take this plus x and this -6, and I'm going to put them on the right-hand side of the equal sign. So I'll get what? 2y is equal to positive x will come across to the right as negative x, and -6 will come across to the right as positive 6. Very important for you to know how to get the gradient from the equation of a line. And what we want to do now is to get this y by itself. So to get that y by itself, this 2 in front of y must go. So this is 2 multiplied by y. So let's do the opposite in operation. You divide 2y by 2, and you're going to divide -x plus 6 by 2 as well. So your 2 y's now will divide into each other, and you're going to get y by itself. But this is still not in the form y equal to mx plus c. To make it or to represent it in that form, what you're going to do is separate these two terms. You're going to separate it by writing it as what? -x over 2. -x over 2 is the same as -1/2x, which I'll write shortly, plus 6 over 2. So you have to separate it at that point. Get familiar? We have to separate it at that point. So this equation now we're going to write as this. We're going to write the equation as y is equal to -1/2x. -x over 2 is the same as -1/2, -1 over 2x, plus 2 into 6 is 3. Make sure you know this class. For tomorrow's exam, if you're given the equation of a line, you can get the gradient from the equation by making sure it's written in the form y equal to mx plus c, making y the subject. So therefore, the gradient is the number located in front of x. And the gradient there is what? -1/2. So now that you know the gradient of L, which is -1/2, from the equation of the line, let me just put here gradient of M, comma, is 2, and the gradient of L, comma, M is -1/2. So we have the gradients of both lines. Of course, I put comma and M, of course, to represent your gradient. So now, let's take those two gradients and multiply them. Let's multiply them and see what we're going to get. When I multiply the gradient of M by the gradient of L, let's see if I'm going to get -1. This will be what? 2 multiplied by -1/2, and 2 multiplied by -1/2 gives -1. So you know what that has proven there? It has proven that the line L and the line M meet at right angles. They are perpendicular to each other. All right? So this is important to know. So we knew the gradient of M, we worked that out before, so we know that's 2. And then we found the gradient of L by means of the equation of the line, making Y the subject, doing a bit of separating there. And when we separated, we know that the number in front of X represents a gradient, which we got as -1/2. And when you multiply both gradients, you got -1. So make sure you know that for tomorrow. All right? So you know that line L and M are perpendicular. Any questions?
You know the lines are parallel.
Ah, good question. Real good question, right? So how you know if lines are parallel? So if they are perpendicular, when you multiply them, both gradients, you're supposed to get -1. Parallel lines, you know, they move in the same direction, right? They never meet each other. So you know when two lines are parallel when the gradients are the same. So if you know the gradient of this line is 2, and you got the gradient of this line to also be 2, then they are parallel. Good? Clear on that? So they are parallel when the gradients are the same. All right? And there was just one more part to this question, which was a straightforward part. It says line L and line M represent the graph of a pair of simultaneous equations. And we did simultaneous equations earlier, right? Using the graph on page 11, which is this graph here, write down the solution to the pair of simultaneous equations. Now, earlier we did solving a pair of equations simultaneously. We used the method of elimination and we got the coordinates of the point of intersection. You have a graph here, you can solve a pair of equations graphically, simultaneous equations graphically. You have the two lines here on the graph, staring in the face, right? Both lines on the graph. So you look to see where both lines meet. Where they intersect, the point of intersection will be your solution to solving a pair of equations simultaneously via the graph. So in part E of this question, part E, I'll just write part E here. So this is part D, and this is part E here. Part E asks us to write down the solution of the pair of simultaneous equations. That's just one simple answer. It's 2, 2, the coordinates of the point of intersection. Yeah? So the answer here will be 2, 2. That's your solution. Yeah? That's why I went for 1 mark. Easy. All right. So what I'm going to do now, students requested, right, functions. Circle theorems. Well, a lot of requests. So remember, it's supposed to be a 2-hour session, right? but let's see what we can do. All right. Okay. So functions. Let's try to do our functions. And I know persons are requesting as well completion of squares. I want to do a completion of squares. And let's see what are vectors and also what else? Circle theorems. Yeah. So let's see what we get in. I know someone asked for bearings too. Let's see what can be done. I know there's a lot on the table. So let's see. All right. Functions. So let's see if we can do a quick functions question. Now, I'm putting the question on the board. I know many of us may not see it. Like I said, we're going to work on this. Yeah? So next live, we're going to work on the visual of the PowerPoint. Yeah? All right. Now, and like I said, I will write down the question. So look at it here, class. We have here all right. So I'm going to write it down. Functions f and g are defined by, you have f of x. Now, this is going to come in the exam tomorrow for sure. For sure. Okay, close your eyes. And you know that's coming. Yeah, you know that's coming. No ifs, no buts. Yeah, functions for sure. Yeah, close your eyes and enter the exam room. When you open, you're going to see functions. Yeah, right? Sorry? Yeah. So we have here what? F of x is equal to 6x plus 8 and g of x is equal to 2x minus 2 over 3. Let's make sure we know functions for tomorrow exam, right? Now I'm going to take down this PowerPoint. Let's make sure we know it. They want us to find 1 g of a half. You see something like this in your exam tomorrow, g of a half. What g of a half means? This means, of course, f of x and g of x are functions. They're also called images of x. And what you want to do is find g of a half. If you see a number in brackets, note your result will be a value. Good? Suppose I get a value. If you saw x in the brackets, your answer will be an expression. Just understand the difference between the two, right? So you want to find g of a half. A number is in the brackets, so you're going to get a value as your answer. But to get the value for g of a half is simply a case of where you see x in your function or the expression representing that function, where you see x in that expression, you're going to replace it with a half. It's simple substitution. Simple substitution. So you're focusing on g of x, not this one here, not f of x, sir. You're focusing on g of x because they asked for g of a half. So you're replacing x with a half minus 2 over 3. And let's work out what is a half minus 2. This is a half minus 2 over 1. You find the LCM. When you're subtracting or adding fractions, you find the LCM. 2 into 2 is 1. 1 by 1 is 1. Bring down that subtraction sign. Divide 1 into 2, which is what? 2. Multiply 2 by 2, which will give you what? 4. So you're simplifying. You're not going to leave your answer like this. You want to simplify it as much as possible. So 1 minus 4 will give what? Negative 3. And of course, we maintain the LCM 2. So a half minus 2 is negative 3 over 2, or negative 1.5. Negative 3 over 2 over 3. And let's simplify that further. What is negative 3 over 2 over 3? It's the same as negative 3 over 2 divided by your vinculum division symbol, 3 over 1. So this 3 here is the same as 3 over 1. And now let's further simplify that. That will be what? Negative 3 over 2. Change the division sign to a multiplication sign, and you invert the second fraction to become a third. And when you simplify that through multiplication, you look to see what factors are common to both numerator and denominator. 3 into 3 is 1. 3 into 3 is 1. So you're going to get here, negative 1 by 1 is negative 1. 2 by 1 is 2. So the answer for g of a half is negative a half. So you simply replace x with a half. Work out what is a half minus 2, which is negative 3 over 2. You get that in your numerator. And then you're going to divide that by 3. So sometimes when students see things, when you see a makeup like this, setup like that, they get confused. But this is simply what? Negative 3 over 2. Vinculum is a division sign. 3 is 3 over 1. Just carry out simple division of fractions. Yeah? Change the division to multiplication, invert the second fraction, and then you multiply to get negative a half. Right? Now, part 2 of this question asks us. Now, you'll always see this in the exam. 2. They want you to find gf of x. Gf of x, class. You always see that in the exam. You want to make sure you know how to treat it. You see that in the exam tomorrow, you smile. You say, yes, Mr. Moyo showed me that last night, right? So, look what's happening. You want to find gf of x. So, what's going to happen? You are going to, when you see gf of x, it means you're taking these two individual functions and you're going to combine them together. You want to bring them together. This is why it's called a composite function. So you're bringing them together as one function. So you're going to bring them together. This is how you're going to bring them together. You always take the function on the right-hand side and you're going to substitute it into the function on the left-hand side. The function on the right-hand side is f of x. So you're going to take the expression, this expression here for f of x, and you're going to substitute it into g of x. So when you see this x in g of x, you're going to replace this x with this whole expression here. All right? But to make it easy, what I like to tell students is write G, write the function on the left, G as is, replace the f of x with the 6x minus 6x plus 8. You're replacing that f of x with the 6x plus 8. And g of 6x plus 8 means, like what we did with g of a half, I replace x with a half. G of 6x plus 8 means you're going to replace x with 6x plus 8. So it becomes what? 6x plus 8 minus 2 over 3. All right? Which becomes what? 6x and plus 8 minus 2 is what? Plus 6 over 3. And then they ask you to do what? They ask you to write it in its simplest form. That's the question here. Write it in its simplest form. So you're not going to leave it like this. You can simplify it even further. How? We're going to simply express this as 6x plus 6 over 3. Remember when we dealt with the coordinate geometry question just now there? And when we had a fraction like that, we have to separate it. The same thing we're going to do here. So you're not going to say 3 into 3, 1, 3 into 6, 2. I can't do that. 3 into 3, 1, 3 into 6, 2. No. Please do not do that. Because of this addition sign, you cannot just divide the denominator into the numerator. What you have to do, class, is separate it. So you're going to write it as 6x over 3 plus 6 over 3. You have to separate it first and then simplify it. So it becomes what? 3 into 6x is 2x. 3 into 6 is 2. And that's the answer simplified. I remember always show steps, steps, steps. That's what they get marks for. So gf of x, this represents the combined function for g and f. That represents the combined function for g and f. So you always take the function on the right. Just remember that in your exam tomorrow, and you substitute it into the function on the left. Don't forget that. Always right into left. Good? All right. So if they ask you, they have here now. They have here part 3. They have this, which you always see in our functions, but they must ask you this tomorrow. Must. Part 3. F inverse of x. Must ask you that tomorrow. They must ask you to find the inverse of a function. F to the power of -1. If you see g to the power of -1, it means the inverse of the function. And just remember, to find the inverse of a function, you're going to carry out just 3 steps. Just remember that, just 3 steps. That's all it is, 3 steps. What are the 3 steps? Because you're finding the inverse of f, this is what we're focusing on, not that g. We're focusing on this one here. You're finding the inverse of f of x. The 3 steps are, you let f of x be y. F of x and g of x both mean y. They both mean y. So you let f of x be y. So y is equal to 6x plus 8. That's your first step. Just remember that first step. You let y be equal to the expression. Good? Your second step is to interchange x and y. So where you see y, you're going to replace it with what? X. And where you see x, you're going to replace it with what? Y. And then you have the third step. And I'm going to mark it out. I'll put step 1. Step 1. Right? Let me put step 2. Now, you're not going to write step 1, step 2 in your exam. Right? I'm just writing so you know the steps, right? Step 1, step 2. Right? And your final step is to make y the subject of the formula. All right? So you're going to make y the subject of the formula. This is step 3. So this is where your knowledge of transposition will come into play. All right? And sorry, we didn't do this a lot earlier because, I would have gone through all the topics that you all say, you've been fully ready for that exam tomorrow. And I know we're ready, but, I would have had more time to explain certain topics, yeah? But let's look at it here. This is what? X is equal to 6y plus 8. Let's make y the subject. So to make y the subject, it means that this positive 8 and that 6 must be removed to get y by itself. We are going to remove plus 8 first. So to remove plus 8, you're going to minus 8 from both sides. Some students like to take the positive 8, bring it over, change the sign, no problem. So you're going to get x minus 8 is equal to 6y, and therefore to get y by itself, the 6 in front of y must go. This is 6 multiplied by y. So the opposite of multiplication is division. You divide in 6y by 6, and an equation is about balance. If it's done to one side, you must do it to the other. So when the two 6's divide into each other, y becomes the subject, because that's what they ask you to do, make y the subject, and you're going to get x minus 8 all over 6. And at the end, don't leave your answer just like that. State at the end, therefore, f inverse of x, make sure you put this at the end. F inverse of x is equal to x minus 8 all over 6. And that there is your expression for f inverse of x. If they had asked you for, say, suppose I went further. This wasn't any question, but suppose I went further and they asked you to find what? F inverse of, say, 10. Good? F inverse of 10. Because you have the expression for f inverse of x, then to find f inverse of 10, you simply replace x with 10. And then you work it out. So you're going to get 10 minus 8 over 6. 10 minus 8 is 2 over 6. And therefore you have a 3. Alright? So that asks something like that. Okay? So this here, you know, is a bit of functions. Composite function combining inverse of a function, 3 steps. Okay? Alright. So let's look at I'll look at okay. You want me to look at the bearings first, or you want me to look at completion of squares first? You tell me. Which one you want me to look at first? Bearings or completion of squares? A bearings question or completion of squares question?
Bearings.
Bearings? All right, let's look at the bearings. Good? So let's look at the bearings. Let's make sure we understand, you know, how to treat with bearings, right? Now with bearings, they bring the question in 2 ways. They might bring the question where you have to, you know, draw the diagram based on the information, or sometimes they'll give you the diagram. You have to use, you know, the diagram to answer certain questions, okay? What I'm going to do is to look at one where they just give you the question and you have to create a diagram from the question. And normally if that's the case, you know, that goes for about, sometimes that goes for about 5 marks, yeah? And then what comes into play with bearings, some important rules will come into play, right? So the rules that will come into play with bearings, these rules come into play. 1, you have the cosine rule. You have 2, sine rule. You see those 2 rules? Those 2 rules are very important rules. You see it a lot in a bearings question. And bearings certainly, from the history of the exam paper, you know, you'll see that along with a circle theorems on the geometry and trigonometry part of the paper. So let's look at this question. So I know we're not seeing it properly, but let me read it out. It says here, a boat, and let me write it out. A boat leaves a dock at point A. A dock at point A. So a boat is leaving a dock at point A and travels a distance of 15 kilometers to point B. on a bearing of 135 degrees. On a bearing of 135 degrees. Good? It says here the boat then changes course and travels. So the boat then changes course and travels a distance and travels for a distance of 8 kilometers to point C on a bearing of 60 degrees. All right? They want us to do A. A is to illustrate the above information in a clearly labeled diagram. So they want us to represent, you see this information here? They want us to represent this information on a diagram. And they require certain things on that diagram. Right here what they want us to show on the diagram. They want us to show on the diagram, show on diagram, right? They want us to show 1, the north direction. All right, I'll just explain, a little of the bearings before we get into the question. 2, the bearings of 135 degrees and 60 degrees. And they also want us to show the distances of 8 kilometers and 15 kilometers. All right? So they want us to take this information we have here, you see this information, and they want us to put it on a diagram. Good? But first you have to understand what is a bearing. A bearing is an angle, right? A bearing is not the little part you see in the car, right? So the bearing is an what? An angle. And what that bearing does, it shows the position of one object relative to another object. So a bearing is an angle. So anytime you tell you bearing, you're thinking angle, all right? And what it will do, it will help you to locate the position of some object from another. Done? So note with bearings, 1, you must always set up what you call a north line. So you must have that in your diagram, a north line. And you always move in a clockwise direction. So to show your bearing, which is the angle, you must set up that north line and you must move in a clockwise direction from the north line. Don't forget that, right? You're going to see hopefully a bearings question in the exam, and once you see it, you're going to ace it, right? Now, what also will come in bearings? Well, what we need to also know about bearings, the angle for your bearings, it's normally represented using 3 digits. This you have 60 degrees here and you have 060. 60 degrees will be 2 digits, but you put 3 digits, 060. 135 already has 3 digits. Good? But 3 things. A bearing is an angle, shows the position of one object relative to another. A bearing, to show the bearing, you must draw a north line. So you'll see that in your diagrams. And you move in a clockwise direction, and the angle representing your bearing must be in a 3-digit form, right? And what will come into play is this here, cosine and sine. So let's look at this. And of course, I'll explain the cosine and sine rule before we jump into that part where we have to use it, all right? Now, a boat leaves a dock at point A and travels a distance of 15 kilometers to point B on a bearing of 135 degrees. Good? The boat then changes course and travels a distance of 8 kilometers to point C on a bearing of 60 degrees. They want us to illustrate north direction, these 2 bearings they asked in the question, 135 and 60, and your distance is 8 kilometers and 15 kilometers on your diagram. Good? So to show that diagram, this is what we're going to do. We need to recognize what's the first point we're going to put in our notebook, right? So the first point we're going to put in our notebook, it says a boat leaves a dock at point A. So let this be point A. Right? So the boat leaves the dock at point A. Good? And travels a distance of 15 kilometers to point B on a bearing of 135 degrees. Good? So it travels on a distance of 15 kilometers to point B. Yeah, take care, right? So note, how are we going to show this on our diagram? We have point A. It says that a boat leaves this dock, which is point A, and travels a distance of 15 kilometers to point B. So where is point B? Point B will be somewhere on this board here. Good? Somewhere on that board, point B will be. But what will help us to locate point B is the bearing. You see that bearing of 135 degrees? That will help us to locate the point B. Because it says here that point B is on a bearing of 135 degrees from the dock, which is point A. So how do I show my bearing of 135 degrees on the board here? And how am I going to locate where is the position of B on that board? Right now, I don't know where B is. So let me use the bearing to help me to find B from that point A, right? So this is what we do. From that point A, we're going to set up a north line. You see my north line? So that's a north line. Set up that at A. Every north line will have a south line. It's going to have an east and west. Those lines you can remove after. You see these dotted lines? You can remove them after. That's just a gauge. Now, it says here, B is on a bearing of 135 degrees from A. Where is 135 degrees? So with bearings, you always move in a clockwise direction from the north line you have set up. So let's move in a clockwise direction. So I'm going to move in a clockwise direction. So this will be what? This is 90, and we just approximating here. You can use a protractor and measure accurately. This is 90. This, of course, between 90 and 180, 135 will be somewhere around here. So let me just approximate. I'm assuming that's 135, right? And I can draw now a line from A to B. So I've located B's position from A. Yeah? This is the bearing of 135 degrees. So I set up my north line at A. All right? Always remember, set up the north line. That's important for you to draw your bearing and hence locate the point that is required from A. The point that is required from A is your point B. How are we going to locate it? Draw that north line from A, move in a clockwise direction using the bearing given of 135 degrees. All right? Everybody, we clear on that? We clear how I got how I have located B from A using the bearing of 135. I can see a thumb, short thumbs. We clear how I got B from A? Yeah. Short thumbs. Right, everybody good? Nice. Now it says here, the boat then changes course and travels for a distance of 8 kilometers to point C on a bearing of 60 degrees. So the boat will then change course. So we're traveling from B and now we're moving to what? C. But where is C position? I don't know where is C's position on that board. We don't know. But we can find it, not so? By using the what? Bearing. B is on a bearing of what? 60 degrees from, sorry, C is on a bearing of what? 60 degrees from B. Yeah? So let's show that. Let's show that bearing of 60 degrees from B so we can find that point C. So at the point B, we draw a north line. Everybody seen your north line? Yeah? Every north line will have a south, east, and west. Again, these dotted lines you can remove after, right? That's just a guide. And with your bearing, that angle, you move in a clockwise direction from the north line. So let's move in a clockwise direction from the north line, and so we can locate C. So 60 degrees, on a bearing of 60 degrees. From our north line, this is 90, between the north line and this line running east, this is 90. So let's just estimate or approximate 60. From my north line, I move in a clockwise direction. So I'm assuming 60 is somewhere here. Again, you can take a protractor and measure it accurately if you want, right? So we're going to get 60 degrees. And I'm going to draw a line from B to C. All right? So this is C here. And don't forget, we have to put the distances. The distance of B from A is 15 kilometers. So make sure you put 15 kilometers on your diagram. And the distance of C from B is 8 kilometers. So because it's 8 kilometers, you can make the distance a bit shorter. Right? This is 15, make 8 a bit shorter. And this here is what? 8 kilometers. Don't forget to include on your diagram as well the bearing of 60 degrees. All right? So you have all that is required on your diagram. You have your north directions. You see your north directions. You have your bearings of 135 degrees and 60 degrees. We see them on the diagram. And you have your distances of 8 kilometers and 15 kilometers. We see them on the diagram. All right? Everybody good with that diagram set up? You see those thumbs up, thumbs up? Everybody good? Nice. So now the next part of this question, this is where we have some working to do, right? Some calculations. And this is where, you see those two rules I wrote on the board, sine rule and cosine rule, that's where that will come into play. So let me just write down what we need to calculate, all right? We need to calculate, let me erase here. All right, so we have all the information we need on the diagram. So I'm erasing everything here. And we need to calculate one, the distance AC, two, the angle, and that symbol means angle, BCA. We have to find that angle. And three, the bearing of A from C. And the last part of the question normally gives students some trouble when they talk about the bearing of A from C. All right? Now note, what will always in the exam tomorrow, if a bearings question comes, you know this rule will come into play definitely, or two rules will come into play definitely. The sine rule and the cosine rule. Good? So the cosine rule is recognized. So the cosine rule, you must have a triangle, yeah? Yeah? Most times it's a non-right angle triangle, because if it's right angle, you can use Pythagoras theorem or you can use trigonometry, right? Sine, cos, tan. But if it's a triangle that's not right angle, then those two important rules, sine and cosine rule, will come into play. Now, the cosine rule is recognized, very important. If you have two sides, the lengths of two sides, you have the lengths of two sides, A and B represent the lengths of two sides, and you also have this angle, which is called the included angle. So those two sides they have lengths 4, they meet at a common point and create an angle. That angle is called the included angle. So if you have information for two sides and you also have what you call your included angle, yeah, then the cosine rule will be used to find the unknown side. So suppose the unknown side is C, and you look opposite to C. And you observe, you have two known sides and an included angle. Remember what's included angle? Two sides meet to form a point. This is not an included angle. If you have something like this, you have a side here, you have a side here, and you have an angle here. That is not an included angle. The included angle is where the two known sides meet to form a point, and the angle created at that point is your included angle between these two known sides. All right, this is not an included angle, so know the difference, right? So once you observe that, you know that automatically this rule called the cosine rule will come into play. And the cosine rule is a nice simple formula, right? It's simply this. You look at the side you have to find, squared is equal to the two known sides, and this comes in the formula sheet, by the way, the two known sides, which will be a squared plus b squared, two known sides, minus 2ab, two known sides, cos the angle they form, which is the included angle, theta. That's the cosine rule. So your two, the side you have to find opposite. When you look opposite, you see two known sides and an included angle. So you know it's cosine rule. What's the formula? C squared, unknown side squared, is equal to a squared plus b squared minus 2ab cos theta. All right? So that's the cosine rule. The sine rule, on the other hand, so the sine rule, applied as well to a triangle that's not right angle. All right? And the sine rule, if you have two sides and an angle, or two angles and a side, then the sine rule can be implemented. Once you do not have two known sides and an included angle, the sine rule will automatically come into play. Right? So if you have, for example, this angle at A, this is my angle at B. Let me put this angle at A here. This is B, point B, point A, and this is point C. Put this angle at C. Right? Now, with the cosine rule or sine rule, which I should have stated here, but anyway, let's deal with this. I have here, if I have my vertex A, this is how you label the sides first, right? And the same things apply to the cosine rule. If this is my vertex at A, the side opposite the vertex at A, you always use a common letter tip. So this will be common A. If this is my vertex at B, the side opposite to the vertex at B, you always label it as a common letter. If this is my vertex at C, the side opposite, I label it using my common letter. So the sine rule is about ratios. Keep that in mind. Right? It's about ratios. But it is used when you have two sides and an angle, or two angles and a side. No included angle, right? If there are two sides and an included angle, cosine rule. If there isn't that, then if there are two sides and an angle, or two angles and a side, the sine rule will come into play. And the sine rule is about ratios. So you'll have here common A over sine the angle at A, keeping in mind a ratio is a fraction, is equal to common B over sine the angle at B, is equal to common C over sine the angle at C. That is the sine rule, and that is the cosine rule. You see those two rules always come into play with bearings. All right? Always. So let's see which of those rules we're going to use to help us to find what is required. In this question, they want us to find the distance AC. So the first thing I'm going to do is draw a line connecting A and C. All right, so I connect A to C. Now, when I look at AC, if I have to find this line, when I look opposite to AC, look opposite, what do you see? Two known sides and this angle here. Now, this angle, the included angle must stem all the way up. We are seeing piece of the included angle. This is 60 degrees here, a bearing of 60 degrees. But we can find this little piece here to help us to find the entire included angle. Yeah? We are seeing two known sides. If you look opposite to the side you have to find, one easy way, look opposite to the side you have to find. When you look opposite, if you recognize you have what? Two known sides and an included angle at that fixed point, then you know the cosine rule will be used. But in this case, we don't have the entire included angle. We have part of it, which is 60. But it doesn't mean that we can't get the other part here. We can get the other part by the implementation of something of importance as well that we use in bearings. And what is of importance that we use in bearings will be angles that are applicable to lines that are parallel. So if lines are parallel, and it's very possible you can see questions in the exam tomorrow relating to this. If you have lines that are parallel, there are three important angles that will come into play. You have parallel lines, you have your Z shape, which is known as alternate angles. This angle is equal to that angle. So you have alternate angles. You have the F shape, so shaped like a F. Which are known as corresponding angles to parallel lines. So you can have that coming into play as well. And then the last one that can come into play will be co-interior angles. They are that sort of box shape. So you'll have here these two interior angles. When you add them, you must get 180. So you have these three angles, and this is known as co-interior. So you have these three angles that can be applicable to a bearings question as well. So you have to make sure you pay attention to these angles, they can come into play. So let's see. This is the side you have to find in this triangle. Opposite, what do we observe? Two known sides and an included angle. The included angle, we have part of it. But if we get the other part of it, then we can use the cosine rule to get the length of AC. So how are we going to get the other part of it? And this is where you see these angles I've stated on the board here can come into play to help us. If we look, class, what do we see? Two north lines. Always remember, two north lines are parallel lines. Those are parallel lines. And once they are parallel, these three angles can come into play to help you. So look at it here. If this entire angle is 135 degrees. So let me pull out the shape. This is the shape we're looking at here. I have the two north lines. So I've taken out the two north lines, pull out the shape so you can see. This is the shape we're looking at here, co-interior, right? Co-interior, you have that sort of box shape, two parallel lines. This angle is 135 degrees. This angle here, this little piece right here, let me put it in black. You can find that angle. See this angle here? You can find that angle. And when you find that angle, you can add that angle to 60 so you can get your full included angle, right? And then use your cosine rule to get the length of AC. Let's get this angle here. All we're going to do is use co-interior angles. If this is 135, I'm going to subtract 135 degrees from 180, yeah? And 135 degrees from 180 degrees will give us, that will give us 45 degrees, yeah? So we're going to get 45 degrees. Yeah? So I know that this angle here, you see this angle here? This angle here is 45 degrees. Because I use what? I use the fact that we have co-interior angles. Two lines are parallel. My north lines will recognize or allow me to recognize that. And therefore, look what's going to happen. This entire included angle we have now, this entire angle here is 60 plus 45. This is 105 degrees. That's my included angle. 105 degrees is my included angle. Okay? So sometimes, they'll give you a question where, it's very easy to recognize what's the included angle. This one, you had a little work to do to find it. All right? But, not difficult. Just use the fact that you have co-interior, and you get that 45, you add that to your 60, and you have your included angle. So now, let's get the length of AC. So let me ask before I move on to find the length of AC. Y'all, let me see by a show of thumb. Y'all clear now I got this included angle? By a show of thumb. We clear now I got that 105 degrees? Show of thumb? Right, nice. So let's make sure we clear now we got that 105. So now let's get the length of AC. So this is what we're going to do. Bringing in the cosine rule to help us. So let me remove these pieces of information. And yes, let's use the cosine rule to help us. Let me erase all this. Right, so let's use the cosine rule to help us. So the first thing we do in using the cosine or the sine rule, I'll always advise this, label the sides. So you're going to label the sides. If this is vertex B of the triangle, the side opposite to vertex B, you're going to call it common B. You use a common letter to that vertex. If this is vertex C, the side opposite to vertex C, you use a common letter, common C. If this is vertex A, the side opposite to vertex A, you use a common letter, common A. Good? So after labeling, let us now implement our cosine rule. So the cosine rule is this. To find this distance AC. So AC is otherwise known as common B. So you look opposite, what you're seeing now, two known sides and your included angle. So let's create our formula. It's going to be my common B squared. So using the cosine rule, it's common B squared is equal to my two known sides that meets to form the angle, A squared plus C squared minus my two known sides that I have, 2AC cos the included angle, which is that angle at B. That's your included angle. So make sure you know that rule, cosine rule, how you recognize it. Don't forget that. Make sure you know you recognize it, right? When you look opposite, what you see? Two known sides, included angle, cosine rule, one time, right? So let's substitute. This becomes what? B squared is equal to A, which is what? 8 in brackets all squared. Plus C, which is what? 15 in brackets all squared. Minus 2 times A, which is what? 8 in brackets. C, which is what? 15 in brackets. Cos the angle at B, which is what? 105. Good? Let's break it down. What are we going to get? This will become, let me just quickly grab my calculator here. This becomes what? Of course, 8 squared will be what? 8 squared will be 64. We know 15 squared, of course, will be 225. Good? This will be negative 2 by 8 is 16, negative 16, and negative 16 by 15 will be what? That'll give us negative 240. Cos 105. And let's work out what is cos 105. Cos 105 will give us negative, and make sure your calculator is in degrees when you are doing your calculations, right? Some students make the mistake and the calculator will be in radians. So in your exam tomorrow, make sure your calculator is in degrees, right? So check that first. So this will be what? Negative 0.2588. And you can take about 4 places after the point. You don't have to take, all the numbers after the point. But take about 3 to 4 places after the point. It will help you to get a better approximation to your answer. So look at what's happening here. Students make the mistake. They will say, all right, B squared, 64 plus 225, 64 plus 225 will give us what? 289. Minus 240 times negative 0.2588. Look at the mistake students will make. They'll subtract this 240 from 289 and then multiply that result by negative 0.2588. That's incorrect. Huh? We have to remember, this 2AC cos B is one term. So you have to work out this first. You see this entire thing here? You have to work out that first and then subtract it from 289 or add it to 289. Good? So don't say 240 from 289 and then multiply by 0.2588. That's a common mistake students make. So this becomes what? This will be B squared is equal to 289. Now we're going to multiply negative 240 by negative 0.2588. And let's see what we're going to get. A minus by a minus is a plus. 240 multiplied by 0.2588 will give us 62.112. Yeah? And when you add those two, what are we going to get? 289 plus 62.112 will give us B squared, which is equal to 351.112. And therefore, to get B as your answer, you're going to find the square root of that number. B, which is the length of AC. Remember, common B is the length of AC, yeah? Right? We're going to write AC at the end. So, common B is AC. This will be the square root of 351.112. And what's the square root of 351.112? We're going to get what? This will be square root of 351.112. We're going to get 18.7. 3 kilometers. And because they have the lengths as whole numbers, we can approximate that to the nearest whole number. So that to the nearest whole number, which is the length AC, common B is AC, is equal to 19 kilometers. So that length AC class from your bearings question is equal to 19 kilometers. So this first part here is an important part. So with your bearings question, if you see one tomorrow, and I'm sure you're going to see one, right? Hopefully you see one, right? I'm praying to God that we see one. If you see one tomorrow, then certainly you're going to see the cosine rule. Yeah? Just remember, when you have to find that unknown side and you look opposite to the unknown side, if you see two known sides, they meet at a common point and an angle is formed, one time is the cosine rule. So you label and you use your, set up your equation, substitute, and you work out to get the length of the unknown side. All right? So this part now, part 2, asks us to, all right, so I'm looking at my time, and because of time constraints, I know I wanted to do vectors, but because of time constraints, I may have some challenges doing the vectors and the completion of squares. All right, yeah, because I have to end shortly. Yeah. But after I do this question, I will end the live. Yeah, I have to end it shortly. So this length here, AC, is 19 kilometers. All right. So what we have to do? We have to now find part 2, angle BCA. Now, where is angle BCA? Angle BCA is located where? And this is important for us to recognize. Where is angle BCA located? The letter in the middle is where your angle is located, right? Let's remember that. So my angle BCA is here. You see that angle there? That's right. So you want to find that angle. You want to find that angle. How are you going to find that angle? Right? This is what we're going to do to find the angle. Now you got AC to be 19 kilometers, not so? Good? And we want to find that angle at C. So what we're going to use here, we are going to use, you can use the sine rule to find that angle, because the sine rule, likewise cosine rule, is used to find a side and an unknown angle. Unknown side and unknown angle. So you can use the sine rule, you can even use the cosine rule here too to get that angle. Because the cosine rule, normally to find an angle, you must have 3 sides to find the unknown angle. That's for the cosine rule. But this here, you can also use the sine rule to get an angle. Let me show you all how we're going to use the sine rule. Now, For part 2, which is to find the angle BCA, I'll just erase here. Angle BCA, this is what we're going to do. Using the sine rule, I remember the sine rule is about ratios, right? The sine rule is about ratios. Now, even though I wrote 3 ratios on the board earlier, you're only using 2 out of the 3 because you have to do a bit of cross multiplying and so on to get your answer, right? So, what are the 2 ratios you're going to create? Look how easy you're going to create your ratios. Always look for the unknown. The unknown is this angle at C. You want to find this angle at C, right? And because the sine rule is about ratios, let your first ratio always have the unknown. So the unknown is at C, the angle at C. So let everything in your first ratio involve C. So you're going to put common C over sine the angle at C. So allow the first ratio of your sine rule to have the unknown quantity. So using the sine rule, because I want to find the angle at C, is going to be common C over sine the angle at C. And you allow the other ratio you're going to create to have information for both side and corresponding angle. So if you look at that diagram, where do we have information for both side and corresponding angle? If you look here, remember this is common B, right? We have side B, which we got to be 19 kilometers, and we have the corresponding angle at B, which is 105 degrees. Yeah? If you look at C, if you look at A, sorry, we have side A, but we don't have the angle at A. So therefore, common A over sine the angle at A is out of the question. The other ratio you're going to create is one where there's information for both side and corresponding angle. So that ratio will be common B over sine the angle at B. So your first ratio will have the unknown. Remember, you want to find this angle at C within that triangle. So let your first ratio of the sine rule have the unknown quantity. So you're going to put everything with C. Common C over sine the angle at C is equal to the other ratio is one where there must be information for both side and angle. So that will be what? Obviously, side is 19, corresponding angle is 105 degrees. So you're going to put common B over sine the angle at B. Let's substitute into our rule. This will be what? Common C, which is 15 centimeters, over sine the angle at C is equal to common B, which is 19, over sine the angle at B, which is 105 degrees. Remember, the angle at C is what you want to find, right? So that's why nothing is here. So let's go work it out. This will be what? I'm going to cross multiply. So when I cross multiply, and cross multiplication occurs when you have single fractions on either side of an equal sign, right? So this becomes what? 19 sine the angle at C is equal to 15 by sine 105 degrees. And therefore, what's going to happen? I need to get sine C by itself, sine that angle at C by itself first. So to do so, I'm going to remove this 19 in front of my sine C. And to remove that 19, the opposite of multiplication is division. So this will be 19 sine the angle at C divided by 19. What is done to one side, you must do to the other. 15 by sine 105 degrees divided by 19. Making sure we know the sine rule to find an angle. My two 19s will divide into each other to give me 1, and I'm going to be left with sine C. And now let me work out 15 by sine 105 divided by 19, and let's see what we're going to get. This is 15, so you can put in brackets, you can put this whole thing in your calculator. Oil, okay. So sorry, okay, what you lost with? Let me hear, go ahead. What part of the question you lost with? Go ahead. Yeah, sure. So I just want to hear what part of the question we have some challenges with. So we can bring clarity to that. We clear on the cosine rule? You clear on when I explain the cosine rule? Or is it the part with the sine rule? Just to make sure we're clear. So I can bring some clarity to that. Or how I got common C over sine the angle at C. Right. So how I got this formula? Right. So what we're using to find this angle here, we're going to use the sine rule to find that angle. Right. So normally with bearings, you'll either use the sine rule or the cosine rule. Right. The cosine rule, you can use it to find a side or an angle. Likewise, with the sine rule, you can use it to find a side or an angle. Likewise. Good? Now, you want to find the angle at C, right? And the sine rule is recognized to use one time once you have two sides and an angle. But the angle is not an included angle, right? So the two sides we have here are, let me just pull it out so you can see it. Well, in fact, we have three sides. This is 15, this is 8, and we got this to be 19, right? You want to find this angle at C here. Good? Now, we could have used the cosine rule to find this angle at C, right? This is 105. Yeah? Now, we could have used the cosine rule if you wanted because we have information for three sides. Once you have information for three sides and you want to find an angle, the cosine rule can be used. You could have used the cosine rule here. But the sine rule can also be used because the sine rule is normally used if you have information for two sides and an angle, which is not an included angle. So you see we have two sides. Well, we have three sides, but pick any two sides and an angle, yeah? Or two angles and a side. But remember, if you're saying two sides and an angle, it must not be an included angle. So for example, if we're going with this 19 and 15 kilometers, right? This 105 here, right, is not an included angle. Remember what makes it an included angle? When you have two known sides and they meet to form an angle, that makes it included. All right? That makes it included. So, if we're going with these two sides and that angle, which is not an included angle, then to find this angle at C, we can use the sine rule. The sine rule can be used. And because you want to find this angle at C, one of your ratios for the sine rule must involve C. Because you want to find the angle at C, and that's the thing with the sine rule. Whatever side you have to find or whatever angle you have to find, your first ratio must have that unknown quantity. So if you want to find the angle at C, allow your first ratio to have everything involving C, which is the side at C over sine the angle at C. That's your first ratio. You allow the second ratio on the other side of the equal sign. The second ratio you're creating is one where you must have information for both side and angle. You must have the length of a side and the size of that corresponding angle. Side and corresponding angle. So what do I mean by side and corresponding angle? So for example, if you look at this 19 here, the corresponding angle is the angle opposite to 19. You have information for both side and corresponding angle. And when we label that triangle, this side was what? This side was B, this side was C, and this side was A. All right? So what you have here, and this was labeled point B, this was labeled point A. So if you look here, you have information for side B and its corresponding angle at B. So the other ratio you're creating for your sine rule must have information for both side and corresponding angle. The first ratio of your sine rule must be one where the unknown quantity is in that ratio. And the unknown quantity is at C, the angle at C. So your first ratio must involve everything in relation to C. All right? And then the other ratio you created is one where there's information for both side and its corresponding angle, which will be common B over sine the angle at B. All right? That's a ratio where you have information for both side and angle. I'm not sure if I made it clear. So let me know. Clear? Sure? So remember the first ratio must have the unknown, right? That's why I started with C over sine the angle at C. And the other ratio, you must have information for both side and angle. Easy, right? So now let's continue working it out. What are we going to get here? This becomes what? This becomes sine C, because remember these two 19s will cancel out. Let's work out what is 15 by sine 105 divided by 19. So I'm going to put in brackets, put in my brackets, put in 15 multiplied by brackets 15 multiplied by sine 105 close brackets divided by 19. And I'm going to get on the right of that equal sign 0.7625. And therefore, to get C by itself, I have to remove sine. See, SIN has to be removed to get that angle C by itself. And sine will come across on the other side of the equal sign as sine inverse. Sine to the power of -1 of 0.7625. So your angle C will be sine inverse of that number. So what is sine inverse of that number? Shift sine brackets 0.7625. And we're going to get 49.6 degrees, and we can put it to the nearest whole number. So I'm going to put that as 50 degrees. 050 degrees. Numbers are bearing, right? So you have to put it with 3 digits. So this angle at C, which is the angle BCA, is equal to 50 degrees. And what we use to get it? We use the sine rule. And what's the sine rule? It's about ratios. A ratio is a fraction, right? What's your first ratio? This is my advice. Let the first ratio always have the unknown, whatever you have to find. So you know how to find the angle at C? Let your first ratio have everything involving C. Common C over sine the angle at C. Is equal to, let the other ratio you created, you have information for both sides and corresponding angle, which is common B, which you have as 19, and the corresponding angle at B, which is 105. So you create your equation there, cross multiply, and you solve for your angle at C. All right? So let's look at the last part of this question, and after this part, I have no choice but to end the live, right? Because of time constraints. Yeah? Because of time constraints, I'm going to end the live. So we want to now determine what is the bearing of A from C. Now this part is the part that often gives students trouble. The bearing of A from C. What is that? Yeah? What's the bearing of A from C? We have to determine that. So to find out, this is what we're going to do. We are going to, and remember what's a bearing? First thing, a bearing is an angle. Keep that in mind. A bearing is an angle. And if you have to find the bearing of A from C, what do we do? This is what we do. We set up a north line. And let me erase here. We are going to, because I want the bearing of A from C. A from C. From C, you're going to set up your north line. And a bearing, you always move in a clockwise direction from the north line. So I'm moving in a clockwise direction from my north line all the way around to the line connecting A and C. Remember, they want the bearing of A from C. So from C, I set up my north line and I move in a clockwise direction all the way around to the line connecting A and C. Right? This is the bearing of A from C, and that's the line connecting A to C. So when you start from your north line, you go all the way around to that line connecting A to C. So this entire bearing I want to find, that entire angle I need to find. So the question is, how am I going to find that angle? Look how easy you're going to find that angle, right? Because students might get lost in finding that angle. But I mean, there are several things you can do to find it, right? One thing is this. This angle here, which is a little piece inside of the triangle, we just worked out that to be 50 degrees, right? You know this is 50. That little piece inside of the triangle is 50 degrees. With bearings, every north line, there's a south line. Every north, there's a south. And look at what's happening here. Remember, I told you about when you have a north or south line, and you have, you know, north lines and south lines next to each other, they are parallel. I have this north line here. It is parallel to this line. These two lines are parallel. So I can show where alternate corresponding or co-interior angles can come into play. Look at what's happening here. Look at the Z shape. You all see the Z shape here? See that Z shape? Let me pull it out. This is Z shape here. Right? Look like an N, but it's a Z, right? Z shape. So this angle is 60 degrees here. Then this angle here is also what? 60 degrees. So you see this little piece here? That is 60 degrees. Okay? So you know this is 50, you know this is 60, and this is what? 180 degrees here. All right? This is 180, this is 60, and that is 50. What you have to do now is add those three angles, and that will help you to determine what is the bearing of A from C. Remember, what is a bearing? A bearing is an angle. Yeah? How do we find the bearing? We set up our north line, and we move in a clockwise direction, all the way around, in this case, to the line connecting A and the C. But how are we going to find that bearing? We can subdivide it into different angles. You have this as 50 degrees. You use alternate angles. You got this little piece here as 60 degrees because of alternate angles. And this little piece here is 180 degrees. You just subdivide that angle. And when you subdivide it, your bearing of A from C, that last part there, part 3, and I'll just erase here, the bearing of A from C will be equal to what? 50 degrees plus 60 degrees plus 180 degrees. Yeah? So that is what? 50 plus 60 is 110, and 110 plus 180 is 290 degrees. That is the bearing of A from C. This entire angle here is 290 degrees. Okay? So that's how we got that bearing. So I subdivided that angle. 50, the angle we got in the triangle, alternate angles get 60, and that is 180 degrees. Adding all three to give me 290. Are we clear now? I got that bearing of A from C? How I subdivided the angle to get the bearing? Short term? Yeah, everybody clear? Right, nice. So class, I mean, sorry I have to end the live now, but you know, we have time constraints we have to work within, and yeah, we're gonna end now, right? Yeah, so what I like everyone to do is make sure before that exam tomorrow, make sure you say a prayer, ask for guidance. You know that divine intervention is very important. So make sure you ask for guidance. Make sure you enter that exam tomorrow with a calm mind. You see your questions, open the paper, you strategize. And I'll always advise students, you know, to do the first 6 questions first, because, you know, that's easy marks in the bag. Students normally do well in the first 6 questions. You know, they have some challenges with the latter part of the exam paper, but make sure you strategize. With the latter part, you know, matrices, vectors, that's an easy question to do, right? You can get marks on your matrices. Sorry, I can do our vectors tonight, but the vectors as well is pretty straightforward. Your bearings, your trigonometry and geometry. Sorry, I can do circle theorems with you tonight, because circle theorems, that's an important topic. But the circle theorems and the bearings, right? They bring sometimes hand in hand. And of course, you have with the functions and relations, you have completion of squares. You also have linear programming. They sometimes bring a linear programming, or they may bring they might bring a functions and relations. Yeah, where you have functions and relations. What you just did, they may bring a functions there, right? So let's make sure that we have a calm mind, enter the exam tomorrow, answer every question, show all your working for me, please. Don't leave out anything. And I'm sure we're all going to be successful at the end of the day. All right? So I'm happy everyone could have come on and be a part of this live. And I hope you would have benefited in some way to what was taught this evening, and it can help you in your exam tomorrow. All right? So with that said, look out for more. Don't forget to like and subscribe to my channel. Like and subscribe. Everybody do that now. Let me see y'all subscribe to my channel. Subscribe now. Let me see people subscribe now. So make sure you press that subscribe button. Yeah? So make sure you subscribe to my channel. More videos will be put out. I'm going to probably do a live for ADMAT as well. For those who are doing ADMAT, I'll do a live for ADMAT. I'll also do 1 or 2 videos in preparation for your ADMAT exam, and more videos to come. Right? So with that said, everyone, all the best in your exam tomorrow. Take care.